the classes and their kids. This is June and Kevin from Wonder Workshop. They are the people who helped to bring Dash and Dot to specifically Central York School District and the whole world, because I know that there are people from all over the world using your little robots.
Mm-hmm.
If it's okay with you, we could have you share a little bit about what you do and how you got started, and then we can field some questions from the group. Would that be okay?
Yeah.
Okay.
Sounds good.
Awesome. Okay.
Cool. So I'm June.
Mm-hmm.
I started with Wonder Workshop from the very beginning. When when we launched, we were trying to figure out what to build for kids, and we launched a crowdfunding campaign. And I've been working on getting Dash and Dot into more schools, and now I'm working on building tools to make things easy for teachers and students to learn.
Yeah, so my name is Kevin. I also started almost from the beginning, I think about a month and a half after June.
Mm-hmm.
So I'm a software engineer. My team are responsible for all of the apps and all of the websites that you see that's affiliated with our site. So Wonder and Blockly, I personally built Blockly. So it's been quite a journey, but it's really fun.
Okay.
Yeah. Are there any questions?
Okay. I do have a question for you, a couple, just to get us started. So you said from the beginning, and we're wondering perhaps when the beginning actually was. And if you could tell us a little bit about how you figured out what works for kids and what goes into actually making an app, because I don't think you wake up and you do it. Like, there was a big smile on your face when you said you were able to build Blockly. So if you could share a little bit about that with us, we would really appreciate it.
Okay. Well, I can talk a little bit about when we started and what we did to get to where we are. And then maybe Kevin can talk about building apps, because I don't build apps. We started, so Vikas, who is the CEO, started the company in December, I think, of 2012, right? And then he had previously started another company, sold it to Google, and then he was like, I'm out. He had a kid, and so he wanted to spend time with his daughter. They were traveling, and he went to a couple of countries where this was 2012, so way before code.org started and all the kind of focus on computer science. And so, he was seeing that countries like Vietnam and Estonia and the UK were introducing computer science to kids as young as 6 years old. And so he was thinking, like, how does a 6-year-old program, right? Like, he's a software engineer by trade, and he was like, I don't know if a 6-year-old can write code and all that stuff. And so there was research that said that 6-year-olds, the younger kids, learn with not syntax, which is writing text and code, but they learn through moving stuff around with their hands and solving problems, and things that are like blocks that represent, code, which is kind of how Blockly came about. People took some of the research that was going on and kind of like made it onto the computer. So we really wanted to figure out, what was something tangible that younger children could learn. We had a few ideas, like one of them was a car where you could add parts to it, like physical parts to it, and then it would run whatever code you added to it. There was also the idea of like little cards that you put on the floor, and then a robot with a camera that would scan the cards, and then it would do the program that you put on in order. But we really wanted to create something that was more flexible and had like a low floor but also a high ceiling for programming. So like if you can imagine all these cards or all these parts, if you want to make something complicated, it would just get really messy, or you'd have to buy a lot of stuff. And so that's how kind of like this robot that's connected to the iPad came out. We could make any type of app on the iPad, and there'd be a lot of flexibility for kids to like play games or program. And then the robot could, is like self-contained. It doesn't have to have like a lot of parts in order for it to work. And then, so that's how that happened. And Kevin could talk about how to make apps.
Yeah, and I wanted to add, I think, two more things that I thought I personally am very proud of the whole connected to app without wires is what kind of gives the magical sense of the robot, which is you can do something on the app that is easier and accessible to kids, but now you're making this whole new entity, the robot, move and react to what you're doing. Mm-hmm. The other one is, I think, the robot design itself. As you mentioned, we started off with kind of like car-like things that we can put stuff onto. What happened was when we did testing that it didn't really appeal to girls. Girls were saying, that's my brother's toy. But they were designed to start to cover the wheelbase, designed it to be more spherical, friendlier. The color, the color palette that we picked was meant to be gender neutral. And we ended up with a product that both boys and girls can really be interested in. And I thought that was something that was really great.
Yeah, and we tested a lot with kids while we were developing this. So we would come up with an idea, build it, kind of 3D print stuff and, try to, do it ourselves and then bring it to kids. And then they would kind of like tell us what they think. And we could also see if they were actually learning anything and stuff. And so kids were a really important part of developing the robots.
Yeah, and we bring that same type of process into our app development as well. So we took Blockly, which is an open source from Google. It's similar to Scratch. We knew a lot about Scratch and how effective it is in schools. So we thought, okay, well, let's just port Blockly directly into our app and into our robot and see how that goes. And we've learned a lot along the way. As we were testing, we found that simple things that, for example, I took for granted as an engineer, which is you hit a start button to execute a program, you hit a stop button, that was actually not clear. And even simple things like that. But through testing is when we really honed in on our design and we really understood that, for example, another thing that I took for granted was when our initial version of Blockly, you had to enter in the number. If you want to turn 90 degrees, you had to tap on the block and type 90 and then hit enter. That was totally easy and fine for me. But when we brought it to kids, the act of a keyboard pop up was daunting because I don't think a lot of the children apps didn't have that. That looked more like an adult input.
Yeah, and a lot of kids didn't know what to put in because a lot of them hadn't learned angles yet, and so they don't know what is 90. That's kind of random. So
right. So then we iterated on making it more graphical because while they might not understand what 90 means, they will. If we draw the 90 degree, they can see it and they understand that robot is actually turning this way. So there are all these things that we did in the app, and most of it was a result of hypothesizing but testing with kids and really seeing how they use it. And that's how we iterated on both Blockly and Wonder.
What language do you use to write apps?
Yeah.
You guys want to know that?
I actually used a lot of different languages. Our technical stack is pretty deep. So it spans from C++, Objective-C, Java, JavaScript, C#, and all the different platforms. But I think that's why teaching the concept is more important because once I was familiarized with functions, variables, loops, object orientation programming, it's easy to pick up other languages and use them like a tool, like what a mechanic would with different type of wrench, different type of screwdrivers, and so on and so forth. So I know a lot of languages, but most importantly is to really be able to understand how do we apply programming concepts.
I see that there are some questions here. Do you want us to answer them?
Absolutely.
In the chat? Yeah.
Yep. So the first one was what inspired you to create the apps? And I think that might have been a question before June had actually started to talk.
Mm-hmm.
Okay.
Yeah. Well, we can talk a little bit more about that. So the apps, you know, obviously, like, we wanted to create different ways for kids to be able to program the robots. But the cool thing about making apps is that you can target different ages and different, like, developmental abilities. So for kids who don't read yet, they can use Path or Go because that doesn't involve any letters or, you know, reading. And then for kids who maybe are learning kind of sequential programming using the Hour of Code, they can use Blockly very easily. Wonder is an app that we created that's specifically designed for robots and robotics. So, you know, Blockly is designed for kind of, well, we didn't design, like, Blockly was from scratch and from Google. We, like, changed it so that it would work with our robots, but that wasn't designed for robotics. And so Wonder is more focused on, like, seeing the world around you and responding to things that happen. And so it's kind of a different way of thinking about programming. And then we're also, and I saw there was another question about what future apps we're developing. So we are, can we talk about, like, kind of, we're developing an app that can help kids then make the transition between learning Blockly and learning JavaScript, which is the text-based, getting them to learn more, like, I guess, normal programming, I guess, what a programmer would do, so that they can have even more flexibility, because you can't do, like, everything with Blockly just because you're limited by the number of blocks that are available. So, yeah, do you have anything to add?
Yeah, and I think Jim touched on a lot of it. I'll just say that, so for Blockly, we're really focused on teaching the programming concepts. But some concept is good. It gets you 80% of the way there, but to become actual, like, you know, to program actual programs, we want to get to text-based, you know, like an actual programming language. So we are looking at ways to see how we can bridge the transition between now applying those concepts to actual programming languages to control robots. That will be our next step.
Mm-hmm. And there is a question here, two about Wonder. Based on what you've heard from users, have people seem to think that Blockly or Wonder is easier to pick up on? And then what's the reasoning, and you can tell we have a couple robotics competition folks here, for using Wonder as the programming language for the competition?
Maybe I'll take the Blockly versus Wonder, and you can take the robotics competition.
Okay.
So I think, in my personal opinion, I do believe that both, we create both to be pretty easy to pick up and to be pretty powerful. We actually separated these two as, because exactly what June said, one is more for traditional programming concepts like loops, functions, variables. These are things that you would learn to just, you know, write programs in general. Program for websites, program for stuff in the cloud, so on and so forth. Wonder is created specifically for quote unquote robotics programming. And that's because in the real world, when people program robotics, or even when people program characters in games, they use a very specific paradigm because it mimics very closely to how an entity would think about things. So usually if you think of a human being, at a certain point you're at a certain state, whether you're studying or sleeping, and you react to stimulus, which is the alarm clock, and you can choose to hit a snooze or get up.
Someone saying hi.
Yeah, and I could choose to say hi or look away or something. Right, depending on certain moods or whatever stimulus. And that maps directly to Wonder's robotics programming, which is you're always in a certain state, and depending on the stimulus, depending on the cues, what we call it, is how you will respond to go to the next state. And that's very natural for any character programming. So all the games that you see today uses a variation of that programming paradigm. All of the robotics logic that you see today, all the AI that you see today, use a variation of what Wonder has introduced. And so because we use robots, we thought we would get also expose kids to the robotics programming part of it too. And both are easy and hard, and both scale up and down in their own ways. So that'll be my answer.
Well, Wonder is more visual, and so kids who are more like visual thinkers, because you can like see a loop if you actually put a loop in, whereas Blockly, it's a little bit less like intuitive. Certain things are less intuitive in Blockly, and certain things I think are like less intuitive in Wonder. Like I think if you try to create a complex like behavior chart, so like if on Tuesday you put on these shoes, on Wednesday you do this, on Thursday you do this, it'd be really easy to like draw out with Wonder, but it's like kind of would be cumbersome for you to program in Blockly. And yeah, things like, I guess, like variables and stuff, I think are more intuitive to use in Blockly and less intuitive in Wonder. So it just like depends on the type of problem that you're trying to solve. But we have both because we want kids to be able to like easily solve different types of problems. And then for the robotics competition, so, we wanted to introduce kids because it's a robotics competition. So we wanted to focus on like kind of like programming robots. We also know that not like a lot of kids get exposure to things like Scratch and Blockly throughout the rest of the school year. We kind of wanted to have for kids to like just like like learn something new, a new way of thinking about programming for the competition. It also helps a little bit because it is kind of new to everyone to keep kids kind of like on the even footing. Like some people have a lot of experience with Scratch and some people just have less just because their school doesn't teach it or their school's really super focused on it. So we kind of wanted to like give kids a little bit of an even playing ground since this is like a new thing for a lot of kids.
So thank you for that. We were wondering which of the apps was easiest to write. And then the second question to that is how long did it take to create Dash and Dot from you were just like since the beginning? And where it might be going in the future.
You want to take the Dash and Dot?
Yeah. Okay. So for Dash and Dot, how long did it take to make? So I think, so we were thinking about how to solve the problem of, kind of creating something for kids to learn to code. I think that part took like 6 months. And then when we arrived at kind of Dash and Dot, it probably took another like 3 or 4 months to nail down the final kind of design of it and get it ready so we did a crowdfunding campaign, which is basically like, we create a video and say like, we're going to make this, please support us. And it's just a way of seeing like how much people would like it, because like they would pre-order essentially. And then after that was done, so it took about 3 or 4 months to finalize the design. And then it took about a year.
A year, 3 months maybe, yeah.
Well, it was about exactly a year for us to, because you finish the design of it, but then you have to design it for manufacturing. So you have to redo a lot of the electronics so that like a factory can produce it. You have to have like molds made. So it's like, like Dash's head is in this like shape. And so we had to like create molds for all of the parts of Dash and all of the parts of Dot so that it could like just go through a factory and just, be able to like make it, make a lot of them really easily. But like the upfront time that it takes to do that is like a few months, about 5 or so months. And so that entire process of like, okay, translating it from, we hacked together this prototype with Arduinos and like even custom electronics, and then getting it to where the factory could actually produce the first one took about a year.
Yeah. And for the question of which apps was the easiest to write, so in my opinion, I think Blockly was easier to write just because we were able to partner with Google and grab what they already had and change it to apply for our scenario. You know, we stripped out some of the blocks that are not applicable for robots, and we added new robot blocks, but we were able to get things like repeat loops and so on and so forth for free. With Wonder, it was a complete new way of thinking. It was a complete new app to write. We had a lot of issues even with just how do we make sure that we visually communicate. You drag in to connect the states. What happens when states are sitting on top of each other? We have to make space for it. So there's a lot of things that we had to solve, and that made Wonder not only longer to write but harder as well.
Yeah, but I think it's easier to write Wonder than it was to write like Tap and Go, right? Because you're using Unity, which is like
yeah. I mean, technology-wise, also once you figure out all the design, Wonder was easier to maintain and iterate on than it is Blockly, because Blockly was JavaScript and Wonder was on a well-known gaming platform called Unity that abstracted a lot of the work for us.
We've heard about abstracting a lot when we talk about computational thinking. Can you just explain that to us, for some of us that might be a new term?
Can you say that one more time? I want to make sure.
So you had mentioned abstracting, and I know that some of us have talked about what it means to abstract when you work with computational thinking, but for other people that might be a new term. So would you mind explaining what that is?
Okay, yeah, of course. So programming essentially is really breaking big problems down to eventually down to little digestible chunks of problems that you can solve. And when you solve all these little problems, the big problem is then finished. When at least engineers talk about abstractions, it's really to say, of all these problems that you break it down, what are the levels that make sense so that a group of people can solve it? And so, like, for example, when I talked about the abstraction of that Unity provide, is that Unity is a platform that allows us to write the code once, and we can deploy to iOS and we can deploy to Android. So we were very focused on how does the Wonder app user experience work. But after we write that, we only have to write that once, and then we get to deploy to iOS for free. We get to deploy to Android for free, mostly for free. And that's because of the fact that Unity has abstracted that work for us. And that was something that we couldn't do for JavaScript. And so we've had to write our own translation layer to make Blockly work on iOS and to make Blockly work on Android.
Thank you. And Mrs. Antone wants to know how many apps you have personally designed.
Us personally? Probably, at Wonder Workshop, yeah.
Oh, Wonder Workshop personally.
Personally.
So Kevin and I worked a lot on Blockly together, and that's probably like the one that we worked the most on designing.
Right, but I think there's talking about like you yourself. Have you worked on other apps too?
Oh, other than Wonder Workshop.
Yeah, so I play around with apps a lot. So I built, and I'm into like random things. So I built like a fitness tracker app before. I built a scheduling app because I'm very, very into scheduling. I built like a group social. So I built some random things, and these are just for fun. But I think once I got into Wonder Workshop, I kind of stopped all that because there's just a lot of ideas and things that we can build. So I haven't even finished all of the things that I wanted to try out for the robots yet. So.
Yeah, we had a hackathon where I designed a Tamagotchi pet app.
That was awesome. Yeah.
Where you could use you could make like a dash or dot into a pet, and then the app would kind of help you feed it and play games with it and take care of it and stuff.
Yeah, actually, that's a good one to keep talking about because we do have internal hackathons here, and it's basically where adults can be kids too, and see how do we take our robots. So we built stuff like laser tag using just Dash and Dot, and the fact using Dash is a way to be able to recognize other robots. We've actually built a driving course based on the fact that based on our beacons and our distance sensors. What do we build? We built some really cool stuff. Lately we built AI, so we're able to have Dash shoot at random virtual things.
No, virtual reality, not AI.
Oh, sorry.
VR.
I'm sorry about that.
Or AR, augmented reality, right?
Well, we built that too.
Right.
So
you can wear these goggles, or
that's VR.
Okay.
Yeah. But then we had AR where we hold the iPad up and it was able to recognize different things, and Dash then becomes storytelling based on AR. So we have all these things that we kind of build random experiences just to try out how far we can push the robot.
Mm-hmm. Yeah, if you guys have any ideas for apps, you can share them with us too.
So if you wouldn't mind, just to make sure that I am understanding this right, I heard a few things. Number one, you design because of utility, things that will make your life easier, like your scheduling app or your fitness tracker or your social platform. And then it seems like you find a lot of pleasure in finding new ways that you and eventually kids can use the robots.
Mm-hmm.
And it seems like like you said, there's so many possibilities to try them all. And I think that speaks a lot to how creative you are and your passion. So that's pretty cool. Do we want to take a minute? Does anybody have any suggestions for maybe a future hackathon for June and Kevin? And we'll probably have time for maybe a couple. Is that okay?
Yeah.
Okay. Or suggestions.
So do they have to type it in, or can they talk?
You're a host.
Amy, you're muted.
It looks like there's a child in Lizzie's room. I don't see her head or his. Yep. Are you ready to share? I don't know. Let's see. Is there anybody else? You can just come up to the camera and we'll unmute your microphone. Okay. Okay. This is Mrs. Antone's class.
Can you give me one for free?
Hi.
What is your idea?
We were just discussing, I thought the Tamagotchi idea sounds pretty interesting, and I bet that would be very popular.
Yeah. Oh, we're also looking for ideas if you guys want to talk about accessories or attachments for Dash and Dot. Those are cool ideas too.
So would it be okay if I did record this, and if I put this on our blog and then add the question about ideas and accessories that people can comment to that, and then we can share that information with you? Would that be okay?
Yeah. I think that'd be a fun design thinking exercise, and we look forward to hearing what you have to say.
Okay, and I'm just scrolling through one more time to see if anybody else was near the screen, and I don't see that, so I'm guessing that they're probably doing some good thinking right now. Okay, so I know that some of us have our cameras off of people, but I think that it's important that we let June and Kevin know how grateful we are for sharing their time and expertise with us. And so if we could give them thumbs up or a clap so that they can't necessarily hear everybody at once. Oh, you hear some too. Okay.
Yay! Keep coding!
Yep, keep going.